Ever since Benjamin Franklin introduced electricity to modern life, humans just can't get enough of the stuff. Sometimes our demand overwhelms the system, and as millions of us have experienced, we find ourselves in the dark, a blackout. As a scientist and as an energy consumer, I need to find a viable, sustainable energy solution. Some of GE's energy experts developed one of the most fuel-efficient energy resources on the market today, the 9HA gas turbine, also known as Harriet. I'm here at GE Power and Water with Monty Atwell and Gary Weisner to learn more about the new gas turbine. First off, what is a gas turbine?
Well, gas turbine converts a fuel to a torque, which turns a generator. We pull a huge volume of air into the front end.
It sucks in the air at a speed equivalent to blowing up the Goodyear blimp within 10 seconds.
We then take that air and we compress it to 22 times the pressure that you feel here.
All of these blades are compressing that air that gets sucked into the inlet.
The bulk of the air is mixed with fuel and combusted.
This is the bang, because this is where the pressurized air combines with the gas or the fuel.
And we blow that out through the hot section or the turbine section. The expansion that takes place when you release that energy creates the torque that turns a generator that produces the electricity.
The temperatures inside it hotter than the metal can actually cope with.
Roughly 400 degrees higher than the melting point of the base metal.
So why is your turbine not melting every time you turn it on?
We actually induce a thermal barrier coating onto these buckets. You still need air cooling to process that expansion, so there are cooling holes within that component that help to do so.
These tiny little dots.
Tiny holes.
And I hear that this thing is covered with sensors.
Absolutely. That helps us to understand the firing temperatures, it helps us to understand vibrations, and also the pressure.
We're taking it to speeds that the machine doesn't normally run at. We're taking it to pressure ratios the machine doesn't normally run at, or you take it to temperatures that it would never see. We push the limits very hard of what the machine can do, getting that data so we can make our next products better. Our turbine is especially powerful. We got 400 megawatts here in this test stand. 400 megawatts is equivalent to 400,000 homes.
That's a large city.
Yes, it is.
When I started this, to be honest, I'd not really given much thought to where my electricity comes from. Certainly not how a gas turbine works. But seeing the turbine cut open and understanding all the design and engineering that goes into every last part, that was something pretty special. We're all going to have to start thinking more about where our energy comes from if we're going to continue our electricity-powered lifestyles and not face more blackouts. Oh, what? Again? Don't forget to like this video if you enjoyed it, click subscribe, or click on the next video to watch more. Trains have always captured the American imagination. They're a symbol of growth and expansion, the Wild West. But when they were first invented in the 1800s, reducing emissions wasn't high on anybody's priority list.